Okay, I think it's about time. Good to see so many of you here. I think the competition is quite good at this time, so thank you for showing up. I'm going to tell you a couple of things about the project I've worked on last time. But first, to get an introduction about myself, who am I, finally? That's my name. I'm in the games industry since 2006. I did a multitude of things in games, worked on a couple of games, visualization, sound, gameplay tools. And I joined Blue Byte in Düsseldorf in 2013 to work on Assassin's Creed Identity. So within the next hour, I'm going to walk you through more or less a post-mortem or more or less a project description and a technical point of view of what we did, how we approached the technology, the gameplay, and how we used Unity finally. So this will be the agenda. It will be a little bit more technical in the second half, so I hope no one falls asleep then. So let's talk about the project.
Without any warning whatsoever, Ubisoft has just soft-launched Assassin's Creed Identity onto the Australian App Store. Though we've only had a very quick look at it, it appears to be the closest thing to a full Assassin's Creed game we've ever seen on iOS. Described as an action RPG, the game puts you in control of your own customized assassin and then drops you into randomly generated sandbox missions. You can roam around a fully 3D Renaissance Italy, dispatching dudes and completing objectives over 16 different mission types. There's also a social aspect, which allows you to rope in other players from around the world to assist you in your murderous missions. We're psyched to see whether Assassin's Creed Identity can live up to its promise, and we'll have a full hands-on for you later today. Those of you in Australia can download the game for free right now. The rest of you will have to wait until the game goes global.
So yeah, that's the game. I guess a couple of you might not have heard of it yet, because as he said, it's in soft launch currently in Australia and New Zealand. It's in restricted country launch. And it's not about the identity of the Assassin's Creed brand, as I heard a couple of people talking. It's really a game that's called like that. So what was the main goal when we made the game? As you saw, it looks like a real Assassin's Creed. So the main goal was really to deliver a high-profile Assassin's Creed gameplay on a free-to-play environment on mobile, which is very ambitious to start out. We are in production since September 2013, and the restricted launch was in October 2014 already. So the video is from the launch date. And with the scope of the project and the stuff we want to deliver, it's considered to be a flagship project for Blue Byte. So we had quite some commitment in regards to people working on it and to resources to work with. And we are, as almost usual within Ubisoft, this is a cross-studio collaboration as well. So we work with Pune in India, with Chengdu in China, and with Montreal in Canada, who is, of course, the head studio for all Assassin's Creed brands regards. So when we got all these requirements collected, we thought, what engine could we choose? And I just want to elaborate a little bit on why we choose the engine we've chosen. We need something to prototype fast, because it's the first real big in-house mobile game we worked on. And we needed to get a grip on the technology and to prototype. So we needed something that supports that. And we needed an editor framework that is really easy to understand and extend, because we know the importance of tools. Blue Byte is a quite old studio with lots of tradition, and they have lots of seniority in there, so they know the importance of tools. And also we need an engine that supports mobile, because Assassin's Creed is done in using the Anvil engine, as you might know. But the Anvil engine is not made for mobile. So we needed to do something else. And it should be artist-driven. It should be a lot strong focus on being extensible for an artist to be used without too much tool coding support. And of course we needed some flexible licensing, because not everyone needs to deploy it to an iOS and Android target. So that's why we, in the end, came up with Unity as an engine. And here's a screenshot of our game running in Unity, and with all the environment we have around it. So with having Unity chosen as the engine of choice, one of the big questions as well is how could we get all the content into the game? You might have noticed that the content you saw in the trailer in the beginning showed the original Renaissance era assets. And we wanted to get this complete art style and get this feeling recaptured that made Assassin's Creed 2 and the Brotherhood trilogy so successful. So I want to elaborate a bit on the content creation next. So what we did is we got our hands on to the original Assassin's Creed assets that are done, or the games are done with Anvil, and they use 3D Studio Max as an editor. So we got our hands on the original assets, and we were able to export them from the engine, load them into 3D Studio Max, and prepare them using our own Max scripts. And then we used the existing FBX export-import functionality in 3D Studio Max and in Unity to be able to get the assets into the game, where we polished them and gave them some final touch in Düsseldorf and in Chengdu as well. So, as said, we wanted to recapture this signature Renaissance era mood. So there's some concept art for Assassin's Creed 2, where you have the colors and the original feeling for the game. And we wanted to have the basis with the original assets to get that done, but we had a very tight memory budget for sure. I mean, it's a mobile game, so we defined a number of 100 megabytes that should be enough for the level art to fit in, which turned out to be a really tight limit. And but we needed something big anyway, because we wanted to still deliver some sort of open world-ish gameplay, even using levels. So we used Unity, so we did not create an open world game for sure. And with support of Unity, we were able to get a lot of things sort of for free as well, like static batching to improve the rendering performance, or light maps that just improve the visual quality overall, and light probes that support semi-dynamic character lighting. And with the navigation and links for climbing, we had most of our ingredients already. So you have here like some of the core environments we are about to deliver captured from the editor as well, to get a feeling for diversity in the moods and in the areas we have available. And we were able to sort of push get all content within the limits. There might be one level or another that is a bit above the limits, but still it's really cool to get all that content into the budget. And the similar thing we did with the character art. Assassin's Creed is a character art game, right? I mean, you have lots of animation-driven, character-driven interaction of the player with the game world. So this is, of course, a big and strong focus of the game as well. So we took the original assets again and built a customized rendering pipeline around them to be able to provide a lot of diversity for one and a lot of good performance on the other hand. And we have like a lot of features that were considered console quality features back in the day. We built them into an iOS game, which is like glossy surfaces, ambient occlusion maps, we have specular maps, and all this stuff that is around for a while, but not for mobile too much. And we have lots of high quality, high polygon player characters. We have a level of detail for game characters. And what we also did, we created a system that is able to mix different parts of a character to create lots of different looking and appearing characters. Like if you see in the low polygon example, these are crowd characters that are cosmetic. So they are there to fill the streets, to bring life into the environment. They have exchangeable heads, exchangeable accessories, there's color variation. So we are able to create a big amount of customized characters out of a limited subset. Then there's medium polygon characters like enemy characters. They have the same core functionality, but there we use the color variation as an example to make the characters recognizable for the player. So they have randomized faces as example, or heads, but the equipment itself is defined by the game design. So what colors sort they're bearing and these sort of things. We have different types of enemy characters for sure. And then, of course, the high polygon characters, which is reserved for the players. They are really detailed. We have a vast amount of content for the player characters. And only the animations for itself is a quite remarkable number. As written, we have more than 800 animation clips currently in the state machines, and more than 2,400 transitions, which is providing a lot of dynamic and fluid animation and gameplay. So this is the visual, the content creation part of the game, right? So now the interesting, or the things that a senior programmer is talking to you is that I'm going to elaborate a little bit on the architecture we choose to build the game, to make some dynamic environment, and to get into the architecture decisions we made. So there were three big priorities we had in mind when we created the code structure. One was the collaboration across departments. So we have, despite having a graphics and gameplay department, we had a backend department, we had a UI department, and the arts team that was working in the same editor as every other coder, because it's Unity. So that's something to keep in mind. So it's easy to break the build and then stop other people from working. So that was, of course, another priority we had, to break the build as seldom as possible. I mean, I have to say that it's not possible to never break the build, right? But keep the times the build is broken as low as possible and make it easy to fix it. And third priority, staying agile. It's a mobile game. It's supposed to be very agile, very changing. You have some goals set up in the beginning, but it's about to change over the course of the project. So you have to stay agile, being able to change lots of things in the game without causing too much trouble. So you want to decouple schedules and streamline the processes. So this sort of structure led to this code structure. These priorities led to this code structure. So we have these different code departments. We have different non-coding teams, which is level and environment art, character art, and game design. And they have different connecting points. So what we also did is, from each of the art departments, there are asset bundles created. So these asset bundles are the content packages we are going to deliver. And these content packages finally make it into the client app. We even split the main project and the level art project into different Unity projects to be able to have them working independent of game features as well, because they might prepare stuff that is not even there in the game yet. That's why the tools code, as an example, is the only thing that's really touching the level and environment art. So when we came up with this core structure, what were the prerequisites that made us going that direction? One of them was that we had a very senior team to start with, and lots of people with console and PC games experience. And another thing we had to control is how we could handle the challenge of controlling Unity mono behaviors, because they are controlled natively by the engine, and Unity is a closed box product, right? So you don't have access to what is Unity doing with my game object. So where is that component spawned at which point? So we wanted to have full control of that aspect. And this is also why we decided to separate the game logic from the Unity logic as much as possible. So what this means in the end is, with it a bit confusing chart here, you see that we rebuilt the whole entity component model as well, which is more or less exactly as it's in Unity, but it's more customized to our need. And it's also much easier to tweak to what we need. So we have this for game logic updating entities, as shown in this example. We have a turn handler that's able to have turn and frame-based updates, where the distance of the player to the actual entities defines how often these entities are updated. Visible entities will always get an update, while entities that are far away might get an update only once a second or even less. We interpolated positions a little bit to make sure that the player doesn't notice that too much. This means that we can simulate a whole city on this mobile platform and have a mission system that is able to manipulate the flow of the whole mission at any time for the whole city. And a similar approach, or yeah, it's a different approach for a different problem. So another problem is once you got your entities updated within the short time frame, you have to somehow visualize them. So we came up with a character pooling approach, which means that with all the entities that are currently in the game, you prioritize on their relevance for the gameplay. And if they are relevant and should be shown, then you could decide, do I have space left to show them? Do I not? Is the one that I want to show more important than the one is already shown? And if I find a spot within an existing entity, the system is about to despawn the existing entity and bring the new entity into the game world in the next frame. So we made lots of things planned ahead and not too much happening within the frame. This is even more important if you consider spawning or despawning a character with a complex animation state machine in its back. Because the spawning of these things always takes a lot more time than you can afford with Unity on mobile. So we just made sure that it's not happening too much within a frame. So we also have a caching for this, so to not having to respawn and recreate all these characters whenever they are needed. Because of course we also had to optimize the draw calls, so the characters were baked into meshes to make sure they have usually one draw call, except for the enemies that have weapons attached. So this looks very confusing. So to capture on this one, to come to a conclusion, I would like to show you a small video that showcases the system in action. The video is captured on a PC standalone player, and it's just moving around a city or an environment, and yeah, the video playback is a bit sloppy, but should be okay. So it's just moving around, moving the camera a little bit. There will be one sequence where you can sort of exploit the character spawning and despawning. If you have these characters on the left here, there are 3 guards. And if you rotate the camera fast enough, you will notice the spawning and despawning. I repeat this in 2 times with reduced playback speed. So it should be very obvious what's about to happen there. So the first one is spawning first, and then the one in the distance spawns afterwards. But this only is visible if you exploit the system with really fast camera movements. If you move normally through the environment, as I do here, you don't notice these pop-in artifacts. So you see the result in the end looks pretty good, but still you might wonder why is someone considering rewriting an entity component model for the Unity engine, which is driven by that. So compound entities, which means entities with attached components in Unity, are only clonable by prefabs or existing game objects. And we wanted to have full control to create something like this. There's not much code shown in the presentation. This is one of the occasions. So you might get a feeling for the complexity of this and the amount of control and object orientation we try to get into the game to make it very extensible during its lifetime. And also with something like this, where you have things of several functionality added into one entity, the existing start, awake, update, and fix update methods that Unity provides do not give us enough control of the updating. So we had to do this more or less our own. And was it worth it? So. Because as you see in the text thing, in the code looks pretty complex. So the code complexity grew the overall app size was going to happen. So something like this in the middle here is just, yeah, there's a lot of code behind of it. So it hides complexity at some points. And this also means that you grow the overall app size. When we had Unity with Mono for iOS, we were only able to debug the app for a couple of months, because after that the code size was this big that we weren't able to debug on platform anymore. And also interface and generics caused some trouble with Unity Mono. There's something I'm going to get into this a little bit later. And the translations turn out to be challenging at some points. So IL2CVP is something that came in lately. I'm going to explain or tell something about this later on as well. So with all this talking, is it really worth doing it, and how did we succeed with it? I would say the result is very good. And we have campaign missions that had 100 or more relevant entities. In this screenshot on the right side, you can see with a bit of color highlight, you can see where the entities are placed at. Like the blue one is the player character, the yellow ones are the cosmetic crowd characters, where the red ones in the distance are the enemy guards. And with all that city being simulated, we got 4 milliseconds per frame overhead for game simulation on iPad 4, and for turn updates, we took another 8 milliseconds. So then it's 12 milliseconds. It's really on the edge, but still it's a fluid game experience on an iPad 4. And with that, we had the logic pooling of characters, the one I showed you before. The character pooling system, it was set to have only 10 visible characters and 5 cached. And the character pooling was only for the enemy characters, or for the game relevant entities. So as you see here, the 2 characters visible is not an issue at all for the character pooling. So after having some insights on how the game works and the complexity involved and that we created for it, you might wonder how we made the game content as well in regards to the editor. And I wanted to tell you some stories or some things about the way we extended the Unity editor. So a simple example, or one example, is the behavior tree editor. Our complete game AI is driven by behavior trees. It's also because the behavior trees are quite good to understand visually, because they're a graph, and they're good to debug because they're very atomic in their actions. That's why we choose the behavior trees here as well. And we created our own editor to be able to debug, see, and check the current state of the behavior tree. The crowd as well is reacting to things using the behavior trees, and even in combat we use it to have different enemy things. So there's 2 states of simulation, so to say. The enemy characters are walking through the city with one set of behavior tree, and once they start combat, there's another sort of simulation starting. And as I said, you can, with the extension, you can create, watch, and debug the tree at runtime. Another example is the mission editor, which is turned out to get bigger and bigger over the course of the project. Also because the requirements on the mission and to the gameplay changed a bit. But the whole thing is also implemented using editor extensions. So as you see a bit on this thing on the right side, we use the Unity game objects finally in some big amount, and use the component model to add the mission data to the thing. And this we did in the beginning to do serialization a bit easier by using Unity serialization, but this also changed over the course, showing you the next slide. And we use it in 2 main scenarios. One is handcrafted campaigns, and one is the template for the procedurally generated missions that we provide. So the players will get a big amount of playable content by using these template mission parts that are then mixed to create a new gameplay experience. And as I said, initially we used Unity for serialization. It turned out that the Unity serialization is not the best idea if you want to be flexible in regards to version, and also in regards to the speed and memory overhead. So at some point we switched over to use Google Protopuf implementation for that, and this turned out to be a very good idea. So in a really small data set, we can store a lot of information. Sort of there's 23 kilobytes of a mission that defines a whole flow of a campaign. And for the flow itself, there's another editor extension made, as shown here, which is using GraphViz, which is an external graph plugin that we can add and embed in the Unity editor. And also lots of Unity inspectors written for that. And one of the also very outstanding features is the way how the crowd is done, how the crowd scenes are implemented. So I just wanted to show you a video. Yeah, want to show you a video how the art department or level art is designing the flow for a crowd. So currently, this is the PC editor. So you see the player running around an empty city. The city is empty. On the right hand side, you see the pane with the so you see the pane with the inspector. So we now change to a top-down view, and there's footstep painted into the LS, right? So it's just like a good old paintbrush thing, where you paint the footsteps into the streets. The more footsteps you paint, the more people tend to walk there. So this is the way how to give the first touch to the level. Okay. So then these footsteps are collapsed using a sort of Voronoi diagram. So it's calculating the means of the footsteps to create sectors out of it. And these sectors are then stored into a structure and weighted. So what you see here now is the sectors and their environment, I mean their radius, where they touch. And now you see the meshes that are created to visualize the influence of each of these dots to the crowd graph. So the graph structure defines the amount of people that are expected to walk there. And you can now additionally weight that graph. This is what this current tool is for. So it gives more priority to some of the graph elements. So now it's finally time to spawn some crowd agents. You see the agents moving from top-down perspective. And if you switch back to the player camera, you see immediately the change. So there was no real engine restart whatsoever, no editor restart. The game data has not been dumped to any serialization blob yet. So it's all live edited. So we can now move around the area. As you might have noticed, there's a back alley that has not given the same amount of priority. So this one was more or less empty, while the main spot here is really crowded. So what we now do is exploit the system a little bit, so we spawn a lot of crowd agents. This is, of course, not possible on a mobile platform, but it looks pretty interesting nevertheless. And also you see the variety and the amount of different characters we were able to create with the character system I gave an idea earlier. So the crowd system has some other interesting things. It is also able to figure collisions. So while we do not do inverse kinematics as the main games do, we still have some sort of reaction, right? So if crowd agents dump into each other, they start to play feedback animations. With having so many crowd agents in the scene as here, it's creating some ridiculous situations. But yeah, it's just for showcasing. A lot of tumbling around. Yeah. So yeah, that was a crowd editor. Very impressive showcase in my opinion. And it's just the accessibility of creating these extensions and using it was giving us a lot of opportunities to create a lot of these editors. So we used it for game definition editors as an example. So there's no one using XML files or XML editors or text editors anymore to get to do game data or balancing data. The whole crowd simulation is shown done with that thing. We also have a humanoid viewer that is used to preview how the characters are rendered in the game, because as I said, there's several parts that make up a character. So artists, of course, want to see how does it look like in the real environment. So we have an editor plugin as well, and a tool that is able to spawn any thing you would like to see, any base mesh weapon at any rendering setting. So for all this, we had to write a lot of code, and code is usually written in C# for Unity. So it's time to delve a little bit into this stuff. There's one big important part you always have to have in mind if you talk about C# for Unity, is that it's not Summer in Mono. It's not up to date. So the current state of C# for Unity is something of like 2010 for Summer in Mono. And this means it has still a lot of issues that the old version had, and there are some things that you have to get around with. Luckily, there's a good list for at least the top-level compatibility issues from Unity that you can just see in their documentation. Also, you are able to load .NET 3.5 C# DLLs, which means that you can create your code with Visual Studio as an example, as we did, compile a DLL and be able to use that DLL in separate Unity projects to share the code across. This is what we did for the level environment and for the game project as an example. Also, you have the choice of several IDEs. So you can use Mono Develop, which is shipped with Unity, or you use Visual Studio tools for Unity. So you can still use Visual Studio and Unity in parallel, even debug in runtime from Visual Studio. And this is one of the most important parts for us, which we figured out during the runtime. You can access the whole Mono source code that is used for Unity, for the libs, online. So you can see actually how they implemented their containers or their iterators. That gives a big advantage to understand what exactly is going on. But still, there's a couple of things you have to keep in mind. Something like be careful with interface and generics. So everything that is not in the microcaller, which is the like minimum set of language specifics for C# that comes with Unity, anything that is not in there brings a lot of code into your project that you have to be able to handle, and that bloats your app as well. And this code is, at least for iOS, compiled ahead of time, which means Mono is usually just-in-time language, so it's very efficient in regards to code size usually. This is not the case for iOS platforms, because you have no possibility to do just-in-time compilation on iOS. So if you use a simple generic, like a list of integer as an example, it has to be like fully extended and will get fully extended into the assembly, even with the stripping enabled. And this is something you have to keep in mind. And also something we noticed a lot is the boxing overhead. Like if you pass a value type as an object, as a pointer, it's boxed to make sure it's accessible as a pointer. And this creates overhead. This is put on your garbage allocated memory pressure. So if you do this a lot, then it might hurt you, because garbage allocation and garbage collection takes time. So this is something why you should prevent the for each iterator. There's something more behind the for each, but that's maybe beyond the scope of this talk. And you should also prevent the object type parameters. So we always make sure that you know what sort of object you are using and how you're providing the interfaces. So the talk will be available in the vault as well. So then you can have a look into the links more explicit. One big thing to use and to know, and this is also a good thing that Unity added this to the sort of free version nowadays, because back in the day when we started, the profiler was only available in the pro mode. Now, even with the indie license that you can just use for free, you have the profiler, and you should use it. You should use it a lot to get an understanding for the code and to know what's going on. And you should also know that the allocation differs. So what you see in the Unity editor and what you see in a PC standalone build is not always true on the device as well. So this is why you might want to, for A, use the profiler on the target platform, and for B, create your own measures to profile. Because you have access to something like the current memory footprint, you can use time measures, whatever, and you should implement some sort of profiling toolset that is able to measure and dump your data onto the device, so you can access it offline as well. We did this, and this is even embedded into the runtime profiler in this case. So what you see there is that there's profiling start calls in the stack on the left side. These are our own profiling calls, and whenever the Unity profiler is attached, we just do not lock it locally, but let the Unity profiler get the profiling events. If the Unity profiler is not attached, we lock the data locally and dump it out into a file. What's really new, or quite new still for Unity, is that they brought IL2CPP. IL2CPP is a very it looks a bit like black magic in the end, because what it does cross-compile your code from the interpreted language, which is the output of a C# compilation, into a C file, and then the C file is compiled into the native format for your version. This sounds very, very like a long way to go, but it's the only way to go if you want to stick to C#, and also you still keep platform agnostic this way. But it also improves it also increases the compile times a lot. So for us, it meant that the simple app build went up by 13 minutes, which means from 2 minutes to 15. And if you want to do a simple profiling build, the time went up to 30 minutes. So if you have a coder having to do memory profiling, this is really hurting a lot. Like 30 minutes for a build, and this does not even include getting the stuff from the version control and importing the assets into Unity. The good thing is that you can prepare the project on Windows machines as well. This might be good if you want to use build farms, or if you want to check the output of the cross-compilation. And you have no debugging app size limitation anymore, because what it does, it just more or less directly converts the IL code with including the naming into C code. So you get an idea about what class I'm currently seeing there, what's the function I'm about to see. And you can debug the app, the C code in Xcode, which is very, very handy to get a feeling for the runtime behavior. And there is a series of good blog pages about Unity IL2CPP, so you should really have a look. There's everything from why they did it, over how they create delegates, onto how to create your own garbage collector with IL2CPP. Because this is something we did not yet, which still might be an option, is to create a garbage collector for ourselves, because this might help a lot with these small allocations and the hit that comes in with the default allocator. So, yeah, as I said, everything must be fully qualified in order to pick it up for iOS. But there's the link XML file that is able to you can add namespaces to it, and then you prevent the Android stripping. You prevent the stripping of these assets, these modules, namespaces, whatever, out of the final assembly. And you need this if you just do not directly access the types, as an example, using reflection string-based. And also, if you use interfaces and generics, it's difficult. We ran into 1 or 2 problems with the compiler that just crashed because of code ambiguity, where it wasn't able to figure out what exactly is the coder going to do there. Because if it's an interface using several generic implementations, it's sometimes quite tricky to figure out what's going on. So there's so many issues. Why or what? How can you even do a game with that, right? The thing is, still, Unity supports big and huge code bases, even on mobile. So for us, we have more than 450,000 lines of code, which might not sound big for like the usual big game project, but given it's a mobile game, and given that we have a limited amount of people working on it, it's quite remarkable. Still, there's something that you always should keep in mind when you start your new Unity project, or if you want to do a Unity project. One is, decide if you want to use the microcallib. Using microcallib brings a lot of, it helps you with a lot of dependencies, but it also adds a lot of complexity on the coding side, because you have to implement some basic containers by your own. For us, after all, it would have been very well feasible to use a microcallib, because meanwhile we implemented all the basic functionality ourselves anyway. But to get started, it might be problematic, because you need a lot of ahead time to create some core stuff. The same goes there with multi-threaded updates. Unity itself doesn't support multi-threaded updates, which means whatever you access from Unity from another thread provides you a friendly error message that said, oh, you are not the main update thread, you cannot do that. And then you're done. But of course, it supports the C# threading API. So what you could do is simulate your stuff yourself and then synchronize with the Unity main thread in the main thread. I would love to see this in the gameplay. Sadly, for us, it isn't possible anymore because it's too much interwoven with the Unity structures. And the same or the similar thing with the coding style, you should prevent value type generics because they bloat code. Also, it makes readability a little bit less easy. So you just should keep it simple. The good old KISS principle, it applies here as well. And do a lot of profiling. Profiling is very, very important. So another final conclusion we had after the course of the project, the build times might get really long. So for the environments, we could easily take 9 hours for a fresh project to be loaded and compiled into an asset bundle. And the reason for that is that we want to support multiple texture formats, and the PVR compression, as an example, the PowerVR compression is a very lengthy thing. So it takes ages, and if you have big light maps, as an example, these are 4K textures, it easily might take 10 minutes to just get the light map into the editor. So the build times might get really large, so you have to take this in mind. And the asset bundling is version dependent. So you have to define versions for your importer. And if the version changes, the whole data is re-imported, which means you again suffer the full impact of the duration for a build. And with all that, there's still some obvious but valid points, in my opinion. One is that you should never load any asset or big memory allocation at runtime. This is true for almost any game, but it's the same way true for Unity projects, obviously. And that a big UI texture is still a big UI texture. In this case, if you take, it's also one of the issues with the Retina displays of iOS, right? Because you need high quality, high fidelity textures, but they take a lot of memory, obviously. And if you load them, it might sometimes even take more time, depending on the way how you store them. So for us, it's sometimes that a 2K texture takes 32 megabytes of memory when loading. 60 megabytes are dumped again after this, but that bloats up the memory as well pretty well. So if you do all these things, you might be able to finally find Bliss with Unity as well, which in my opinion we did to a good degree. We adapted a lot to it, we improved our own coding styles, and I think we delivered a really good product overall. So with that, I'm at the end of my talk. Thank you for attending. Please consider the evaluation as well. If you have any questions, anything, feel free. And also mind the jobs page there, very important. Rehire. Come on, come over. Work on awesome stuff. Thank you. So any questions? None? Too late? Ah, over there. Two.
Thank you. Were there many people on your, or two questions, how big was the team, and was there many people on the team who had worked with Assassins prior, like people who understood the animation architecture, for example? Things like that. Was there much of that learned things from previous games that were brought into this one when you rebuilt it?
You mean if you had people working with Assassin's Creed before? Yeah. No, we didn't. We had very senior character artists and very capable guys over there, and they did an awesome job with supporting the animations we got and with the assets to get the animation feeling to it. So it took a while to get used to the tools and to finally, like with some coder support, to get an understanding for the animation state machines and their transitions. But Megin was helping us a lot as a tool to get the fluid animations and dynamic animations done. Yeah. So I think there was a second question.
Hi there. So I was wondering, you said that you use navigation meshes for your crowd simulation. I was wondering, you also use the nav agents for Unity to simulate the crowd, or did you build your own your own crowd simulation system for the agents?
We implemented our own over the course of the project. So we were using the NavMesh agents in the beginning, and we still use the NavMesh agents to calculate the paths because the crowd still has to be on the NavMesh. So we use the agents to get the path calculated, but then the interpolation and movement is done by ourselves. Yeah. Okay, over there. Just okay, I feel there.
Hi. So when you did the profiling, did you also looked after the power consumption and battery life of the device, or you cared only about the performance and FPS?
We were mostly figuring out how to get the overall CPU and memory pressure as low as possible, which also helped with power consumption for sure. But as I said with the iPad 4, we already went the simulation alone above the 10 milliseconds, so we are able to run fluid, but not with like 30 to 50 frames per second. So there was no options to even reduce the frames rendered. So we had the power consumption in mind, but we didn't really focus on it. Yes, one question, yeah.
May I ask which versioning system are you using in combination with Unity?
Excuse me?
The versioning system, so like for coding or?
The versions of Unity we were using?
No, some kind of concurrent version system.
A version control system.
Yeah.
Sorry, my understanding. We are using Perforce for that. Okay. Any more questions, anyone? No? Okay. Oh, there's one. Last one.
A simple one. Will you use Unity again?
Me personally, I would totally, because we got lots of advantages of Unity. It's a black box engine. You need to get into it. I still think that overall the feeling and the things that we were able to do with Unity, we were not being able to do this with our own engine or technology because the ramp-up time would be much too high and expensive. There are some things that are really lacking in Unity, but this you have with any engine, right? So there's always something. And of course, coders complain about other people's code. So it's a bad engine, but I think it's a good engine. It's a good engine, it has good tools, it's a good approach. I'm really happy about that. Okay. So, that's it. Thank you very much.